My name is Sam. I'm one of the organizers. We like to call ourselves co-organizers because Mayor Dad actually does most of the work, and he's the one that actually started the group, got us all together, got us motivated enough to do this. And it's amazing to see because we started last September with one member, that's Mayor Dad. And today we're at 953 members. So I think that deserves a round of applause. So the fact that we're here, this is the 7th one, we host it every month, means that people are getting value from it, and that's what we'd like to see. We also would like to hear from you. Just because it's 6, 7 of us doing this, we don't always have our hooks into every demographic that's using Spark. So we really like you guys to communicate back just to let us know what's going on. And the best way right now is through Slack. And to get into Slack, either go to that domain or email that email just saying I'd like to join Slack with your name, and we'll get you in there. I'd like to say we have a lot of people on Slack, not very engaged right now, but we're hoping to change that very soon. So please join, just so we're all keyed in and all on the same page. So the agenda for today, we're gonna switch things up a little bit. Sean's running a little bit late just because of the construction going on outside. So we'll get Nick Evans, who is working at Shopify. He works in Ottawa office, and he's doing a talk on Spark Streaming. Nick.
It's good to be in the 6. Is that what you guys call it here? No one? Sorry about that. Good to go? Cool. So, hello everyone. I'm Nick. As Sam said, I work at the Ottawa office of Shopify. It's good to be in Toronto. I love this city. I am a Montreal Canadiens fan though. Sorry. Also, this presentation is originally designed for an American audience, so I do have some hockey references just to get a laugh. That's probably not funny to any of you, so. Anyway, so I'm here to talk about real-time risk management using Kafka Python and Spark Streaming. Okay, so Shopify, who's heard of Shopify? You're here, so I guess you've heard of it. Who knows what we do? I'll just give a brief introduction. Okay, so say if you build a nice backpack and you want to sell it online, you can go to shopify.com, create a store, take a picture of it, and within probably 5 minutes, process credit card transactions. And when you get successful and you want to open up a brick and mortar, you can buy an iPad, install our software, and you can sell that bag from inside the store. So that's roughly it. Is it working? There we go. All right, so as I said, we do credit card transactions. And underwriting credit card transactions, as some of you probably know, is risky. There's a potential loss if a stolen credit card is used to make a purchase. As the bank recovers the money from us, that's called a chargeback. If the merchant doesn't have money in their bank account, then we end up having to foot the bill. It's also possible the fraudster might sign up for a store and process stolen credit cards and attempt to, whoops, sorry, clicked the wrong thing. There we go. So it's also possible a fraudster might sign up for a store and process stolen credit cards that they bought online or something like that in an attempt to get us to send money to their bank account. They also might create a fake product that they never intend to ship, like say on a Kickstarter that's going to ship in 3 years from now, and it's going to do all these awesome things, and then they take all the money and run. So we end up footing the bill for those too. So we need to be quick at underwriting. We need to check these credit card transactions and stop bad actors from stealing money from us. The problem is the vast majority of our transactions are legitimate because most of our customers are legitimate and they have a ton of transactions. So we don't want to punish the good merchants by holding money back that they earned just because there are some bad actors. They need the cash flow to keep buying products and doing all the things that are involved in a business. So we also need to avoid losing money because we don't want to give away a lot of money. We could lose hundreds of thousands a month if we were to just ignore the problem. That's probably more now. We need to be sure that our risk analysts are spending their time looking at the right shops and the right credit card transactions to make sure that we're not losing money or not unfairly punishing our good merchants. So here are some legal approved numbers. I think they actually, one of them might be out of date. I think the merchants is high now. Anyways, so we've processed $12 billion in transactions, $12+ billion, I think it is. And we have 200+ merchants around the world. Some big names like Tesla Motors, Wikipedia, GitHub, The Chive. Probably you recognize at least one of those. And I think the statistic is if you're an American citizen, 1 in 6 people, I think, have bought from a Shopify store. Is that correct, Vanessa? Where's Vanessa? Let's see. She's over there. So we have roughly 14K events a second to monitor. That's 1.2 billion a day. I think that math checks out. And we have 7 risk analysts looking through these transactions for signs of fraudulent activities. So here come the hockey references. So our risk analyst is kind of being like a goalie. They're good at saving pucks, but they can get overwhelmed if you fire too many of them in quick succession. There's a lot of pattern, not too much padding, and there's a lot of net space. And as you Canadians will probably realize, apparently our padding size is getting smaller. I don't think Americans really gotten that. That's my friend Alex. He plays on my hockey team. He's a really good goalie. And our risk analysts are really risk analysts. We need to build something that kind of stops the hope factor. Like our risk analysts can look at a lot of these events, but 14K a second is kind of ridiculous. So you need a system that can filter this high volume event stream from that Shopify application so our risk analysts are not overloaded. We need to make sure we're also not sending the non-risky events. Sorry, we need to make sure that we're not sending them non-risky events. And we can make sure that we are sending them risky events. Who studied math and knows like false positive, false negative, whatever, those are, I always get them messed up. We also want to reduce the workload reduce the workload while ensuring the true risky events don't go unnoticed. So we want to build kind of a defense. This guy, Evan, he's a defender. He's smiling. He probably shouldn't be because he's patting the goalie in the back, which is like, nice save. I didn't do my job. So we want defense that can kind of like block the shots and help the goalie out. So Spark Streaming is that wonderful thing that allows us to block some of these shots. It allows us to real-time data processing. We can decide which events need a closer look. We built a stream processor that basically filters out these massive event streams, and then we take the ones of target and we do an HTTPS post to a custom built application that our risk analysts look through and take action. We call this pat down. It's named after like the airport security line. You know, when you fail the line. Echo. Good. So if you fail the check, you kind of get a pat down in a side room. So that's kind of like the analogy. So as any technology talk has to do, we have to do an intro to these technologies. So who's familiar with Kafka? I assume agree, yeah, okay, great number of you. Zookeeper? Less so. And Spark Streaming, I'm hoping that's like pretty much everyone. Or Spark at least, right? I think this is the Spark meetup, right? So I'll just do a quick intro to the three of these. Kafka is a circular message buffer. I think that's the technical term for it. It's a fault-tolerant and distributed publish-subscribe message buffer originally written at LinkedIn. You define a list of topics, you produce messages to those topics, and you consume those messages somewhere else. Or in the same application even. Our main use for it is to log events coming from the Shopify platform, say like a store signs up, an order is processed, a credit card is added, like all these different kinds of things, and then somewhere else can listen to this event stream and do something. Like that could be maybe make the graph a little bit taller on a dashboard, or send an email, or do something like that, or notify risk analysts. So it has ridiculously high throughput due to some engineering decisions. It has a retention policy, meaning that it won't store your data forever. Our default is 7 days. So after 7 days, there's no guarantee that the event will still be around. As an at least once guarantee, meaning that consumers might hear the same message twice, but they'll at least hear it once. That's kind of important. So these topics are also broken up into our partitions, as you can see here. And event ordering is only guaranteed within the partition. We key our events to the partitions based on the shop ID. So shop 1 might go to partition 0, shop 2 might go to partition 1, and then shop 1,000,000 might go to 0. If you look at the events in partition 0, they'll always come in order. If it slows down, you can pretty much just add more computers, and that's what we do. So Zookeeper, I'll just kind of skim over this one. It's just a distributed data store that stores your data in a tree format. We use it to configure our Spark streaming consumer for Kafka. It stores the index of the last message it heard, so if the streaming job is killed or shut down, it can restart from where it left off. So Spark streaming. It's basically just taking RDDs from time 0 to time 1 of events from Kafka and putting them into that RDD, and it just continues to do that for an indeterminate amount of time. It's based on top of Spark. And it's as I said, it uses the RDD, roughly it uses the RDD, so you can map filters and reduces on these things called D streams, which are just discretized streams of RDDs. It's written in Scala, but it has a pretty good Python API. It's gotten better over time. It's mostly, I think if you want to write it in Python, then you can do it in Python. I was talking to some people earlier, and they actually use it in Scala, and I hear that has a lot more power now these days. I'll skip over some of this. Yeah, so the timing of breaking up this data can be customized and should be set based on what type of application you're making. So obviously, if you're putting your data into RDDs and then processing on the RDDs, it's going to be like time 0 to 1 maybe in seconds, time 1 to 2 in seconds, time 2 to 3 in seconds. Ours is like 0 to 30 seconds, and then 31 to 60 seconds. So we do it in 30-second batches. That's just because we're not serving web requests. If you are serving web requests, first of all, you probably shouldn't be using Spark streaming. Second of all, you probably want to use like as small window as possible, like 500 milliseconds. So these kinds of jobs need to be heavily optimized. Unless they're very simple, you need to do a lot of thinking about how you're going to write your jobs just to make sure that the stream processor doesn't fall behind. If you are processing these batches longer than your batch interval, so say ours is 30 seconds, if you're taking 31 seconds to process that, they're processed sequentially, so you'll never ever catch up, you'll fall behind slowly. We don't care too much about timeliness, as long as it's within a couple hours, our risk analysts are happy. So we set it to 30 seconds just because there's a throughput versus, throughput versus timeliness trade-off, I think that's the word for it. Skip that. Okay, so the way it used to work, or it still does work in Spark streaming, is called receivers. Receivers were the original implementation of Spark streaming. I believe the community is moving away from that. It's happening slowly over time, but it's happening. So the way they work, I'll give a quick introduction. So you have events on Kafka from time 0 to time 1. You pop those into an RDD in the next time window. you process in your Spark engine while more events are coming in, and then you build an RDD with those events. Then you keep going. So it loads those chunks of data, those event streams into memory. It then processes it as I was saying, and they're designed to work with all data sources. Here's the important part: they're designed to work with all data sources, not just buffer ones like Kafka. So some data sources might be like watch a directory in HDFS and see if there's new files coming out, and if there are, process them. There's no real way of remembering where you left off for that, and you can't like ask for like all files as of this time because there might be deletions and stuff in between. Or there are other data sources similar to Kafka that just aren't buffered. Like you could have a web server listing, and you could send events via a socket, and it would process those events. That's not buffered. There's no way of getting those events back. So that's why receivers were used. But there are problems when you're using them when you have a data source like Kafka. So those problems. The only way to get at least once delivery makes it very hard to deploy new code. So it's called checkpointing. So when you receive this data, you write it down to HDFS, and then you process it eventually. And if your job dies, like if you're receiving events on a socket and your job dies, it doesn't receive events when it's down, but when it comes back up again, it'll actually start off from those events that it had received before, process them, and then carry out with the new ones. The problem with this is it doesn't just write down the data, it writes down the DAG. So the DAG, who's familiar with the DAG in Spark? Everyone knows what it means? It's basically just a set of instructions that you're applying to that. So what this means is if your job dies, or if you purposely stop your job and you want to start new code running, it will never run that new code because it will just look on disk for the checkpoint and say, oh, it already has a checkpoint that I haven't processed yet, and it will use that old DAG, that old directed acyclic graph of instructions. Yeah, so basically you can't deploy new code unless you get tricky or smart. So another problem is Zookeepers updated with the offsets to start from when the data is received, not when it's processed. So I was saying we use Zookeeper to configure our consumers. So when new events come in, if we go back to that old slide, if I can go back a sec. Is this it? Yeah. If I can go back to this slide, skip through. So in Kafka, you have events, and each event has an offset. That offset sets scope to a partition, but let's just assume we have one partition. So the first event ever emitted will be offset 1, then 2, then 3, then 4, then 5. If you receive up to 5 and you want to write that down to Zookeeper, you tell Zookeeper, hey, I received up to offset 5. Then when you start your job again, it will say, okay, I've already heard up to 5, let's start with 6, 7, 8, 9, 10. So you go back to this slide. When you receive the data, like every 30 seconds you'll receive a new set of data, you tell Zookeeper with Spark Streaming, hey, I've received up to this offset. So the problem is if you don't use checkpointing, basically you will lie and say, I've received up to this data, and then say your job gets killed halfway through processing it, you'll never, ever, ever hear those unprocessed events because you've told it you've heard past that. So it also makes traditional Kafka monitoring tools less useful. A lot of the monitoring tools that we use and other teams use compare the most recently available offset to the last offset you processed, and it will show you kind of like, hey, you're 100 million events behind, maybe you should look into that and fix it, or like make your code faster. If you're processing a chunk like an RDD and it never ever returns, it just kind of cycles there, and there's a loop or something, and it just sticks there for forever. You will never know that in your monitoring tool because it will keep on saying, hey, we received up to here, hey, we received up to here. Meanwhile, there's like a big backlog of events that are there, and you'll never ever ever process those. You'll never ever know that you haven't processed those. And then the third one is we're actually kind of duplicating Kafka because the whole like buffer the events in memory and track it, that's already what Kafka does. So we use Kafka, so we decided to use what's called the Receiverlyst method, or the direct approach. I think that's another term for it. So how that works is it's very simple. You have events coming in from T0 to T1, and then you process them. And then you receive the next batch, and then you process them. As you can see, it's kind of simpler than the last one. There's no middle kind of buffering layer. And it was designed with Kafka in mind, or other data sources like Kafka. You have to handle all the offset management in Zookeeper yourself, but you get a lot of power with this. So before, with the receiverful approach, it would actually do all talking to Zookeeper for you, and it would tell Zookeeper, I've heard up to this event, I've heard up to this event. Excuse me. With the receiverless approach, you actually have to tell Zookeeper yourself and know how to talk to Zookeeper and know how to handle all that kind of stuff and restart if the job fails, which is a little bit more work, but it's a lot more power because you can actually guarantee, I've actually processed this data, now tell Zookeeper that I processed this data, which is very nice. The downside is you have to do a lot more work, as I said. I had a point here, hopefully this will mature, and Spark will give you a nice and simple API. I was talking to one of the core devs, and he said that's likely not going to happen. They're not going to add a API to Zookeeper. It's probably better suited to another library that you can just import or write your own code, which makes sense now after looking at it a little longer. So another downside to the receiver method is the Python documentation definitely falls behind just because it's so bleeding edge and experimental. You'll see, hey, you can do this with the receiverless method in Scala, not in Python. And for us, like, that's kind of a problem just because we use Python. It turns out a lot of the time, all you have to do is just add a very simple function that sits on top of Python and calls other objects. And it's not a lot of work, but sometimes it's missing like a chunk that actually takes work to implement. And the other downside is it's very experimental, as I was saying. It's basically bleeding edge, or was like 2 months ago. I think it's becoming more and more accepted. So the general structure of our streaming jobs. We load the offset, or we load the Kafka offsets from Zookeeper. We ask Zookeeper, hey, what's the last event we've heard on Kafka? If we haven't heard an event in Kafka, we will ask Kafka, what's the earliest available offset of this partition? Then we will tell Spark Streaming to create a D stream that consumes from Kafka, starting at these specified offsets. Then you define your processing step, like filter out the non-risky events. That's just maps and filters and stuff. And then you define your output step. So we post our filtered events out to our third-party, or sorry, our custom-made case management software. And then the last step is after we've done that, we save Kafka offset at the most recently processed event to Zookeeper. So after it's actually made it out to our application, we save those offsets to Zookeeper. So the next time the application starts, it will start off from that one. So that was the last step, but actually all of this stuff is just defining a set of operations, and then you actually start your streaming application. And once you start it, you can't stop it. It will die. You have to start it up again in a new Spark context. So here's an example of some of the filtering that we do. So these are all examples of risky product keywords. Some of them are a little bit puzzling. Hair extensions is the one that everyone always laughs at. Apparently, like, all hair extensions sold online are basically fraud, or a lot of them. Everyone knows what they are? They're like, you can either like clip them onto your hair, or I think you can actually get them like sewn. I don't really understand them, but apparently they're mostly fraud. Vaporizer, I'm sure you all know what that is. Travel package, we're not allowed to sell travel packages via, like through our banking partner. That's why that one's risky. It's not actually fraud, it's just we're not allowed to. I think same with gateway card, and cannabis is obvious. I don't think our banking partner allows us to sell that either. So here's kind of an example of what happens in a very simplified streaming job for this risky products filter. So we have this RDD. It has these product titles or descriptions, whatever, and you can see a couple of them match the risky ones from the last page. So we filter that RDD out to only have products that contain those risky keywords. Then we map them to a JSON-looking object that our application is expecting, and then we do a post to that software. It's pretty simple, and it works really well. Here is kind of a simplified version of what that code looks like. Obviously, there are functions behind all of these, self.this and that, but this is the general structure of the code. It doesn't really do too much more than this. What else? That's pretty much it, yeah. So one big pain point, and everyone I talk to who's done anything more than very basic streaming applications also brings this up, is time-limited aggregations. So say if we're talking about orders now. If we're talking about orders scoped to a shop, and we want to see all new shops, just let's say shops that are newer than 2 days, we want to see their total amount of orders in the last hour and also the value of this order. So say if they've had over $10,000 of orders in the last hour and this current order is $1,000, we want to flag that. Say for example, like that sounds pretty simple, right? And if you have the full data set, that would be pretty simple. You could look at the entire data set and say, yeah, this order happened at this time, and then in the last hour, there was over $1,000 or $10,000, this order is $1,000. That's nice and simple when you have all of the data. When you're doing 30-second batches, that's obviously not as easy. And they're not ready for prime time in Spark. They are working towards it, but it's kind of like, I was originally told it was 2.0, and then someone was saying they heard 2.1 or 2.2. So we'll see, but it's definitely a top priority for the core devs. The reason why they don't work as nicely as you'd think, all the functionality is there, kind of, but it's based on the received time of the event, not the actual event time. So when I was showing you those things earlier, with the T0 to T1 RDD and T1 to T2 RDD, that was the received time of the event. So we have 7 days of data on Kafka, and we maybe make our RDs a maximum of 96 million records or something like that. So maybe that's like 2 hours of data. And we say we process the last 7 days of data in the last 30 seconds, for example. Sorry, I'm confusing myself. Say if we were able to process all that 7 days of data in one RDD, that would all be in the last 30 seconds by the time window degradation, which doesn't make very much sense, because now you're asking, how many orders has this shop had in the last hour? Well, we've processed all this in the last 30 seconds, so that's in the last hour, so they've had $40 million in orders, which clearly has its own problems. You want to do these window degradations based on the event timestamp. Part of that, I believe, I was talking to a couple people, part of that is a limitation in Kafka itself. Not a limitation, but it's something that's not quite done yet. Apparently they're building in event timestamp, the concept of event timestamp, into Kafka as a core object. So you can ask for what's the event timestamp of this event as opposed to the emitted timestamp, and that's going to be useful to help them build it in. I think they also wanted to, I forget what it was. They basically, there was a lot of stuff that needed to be done in order to get working quality time window aggregations. The built-in one also requires checkpointing to be enabled. So even if you didn't care about the fact that they were based off of receive time and not event time, even then there's a problem. You still have to have checkpointing enabled, which again leads to this whole problem of not being able to deploy new code. So if you do deploy your code, you better be sure you never ever want to change it, which is clearly makes sense in some certain engineering cases, but probably not the general one. So we did our own version of time window aggregations. I don't really remember how it worked, mostly because it was incredibly complicated and probably didn't actually work. It seemed to, but every time something looks really complicated, you have trouble understanding what it's doing, it's probably a good indication it's not a very good implementation. So I would say wait until the core developers of Spark Streaming address this. They'll probably have a much better solution. I've heard some other people use Samza, right? So you guys use Samza for this kind of problem? Is that what you're talking about? So I think you use the two of them in together. No, sorry, the two behind you. You do, yeah.
Oh, yeah.
Yeah. Okay, yeah. So they use Samza and Spark Streaming. So that's one solution. It would be nice to have it all in Spark Streaming, but it's not there yet. So the future of Spark Streaming, like I was talking about, time-limited functions, aggregations. It's a necessity for most non-trivial jobs. If you want to do any kind of complex filtering on events based on some kind of state about something involved in that event, like in our case, a shop. If you want to look up the state of a shop, that's kind of tricky. So performance tweaks. We haven't really had any problems with performance. I think there's only one job that wasn't able to catch up, and then we turned something that was an RDD to stream join into a broadcast. Does everyone know what broadcast variables are? They're awesome. Use them if you don't. It's like if you have a small data set, you can send it out to all of your workers, and basically, if you're using Python, you can have a map or a dictionary or a list on all of your workers and use that, and it's very fast. So machine learning. This is obviously the hot topic. Everyone likes to talk about machine learning. We haven't done really anything on this specific thing about the risk management. We could take all of these risk analyst decisions from our third-party application or from our external application and use them to train a model about what kind of events are risky and what aren't. And that would probably be pretty awesome, but I'm sad to say we haven't done that yet. Hopefully in the future. Yeah, exactly. You're saying it's a very good application for machine learning. Yeah, that's like literally what machine. You have a set of training observations with actual like true or false answers, and we're probably going to have. I think we've had a year of data now, so like that's just right for being like training models. So improved monitoring. One unfortunate thing is how much time do I have? Good? Okay. One unfortunate thing is, as I was saying, we monitor based off of offset lag. So what offset are we processing now versus what's the most current available offset on Kafka? That kind of sucks because like if your topic has one event a minute, that is very different from a topic that has a million events a minute, right? Because like, oh no, we have an offset lag of 10. Like in the lower volume topic, that's a big deal, but on the big one, it's like 10, like you're behind by 500,000 all the time, cool. So it would be cool to be able to monitor off of time lag. So this event time was it, this morning, and the most recently available event is now, and that's like X hours of lag, and that'd be cool. But it's very hard again because it's hard to do that with Kafka, and they are working on that. So that's again part of the future. So I said this is the future, but I actually forgot to update this. We actually do use Cassandra in some of our jobs as a lookup for when broadcasts, or when we can't use a broadcast variable because the data is too big. It's really fast, like it works. I thought it was like, hipster technology buzzword, but it's actually kind of cool. I guess that makes me like a hipster, but no, it's cool, try it. And as I said, improved Receiverlyst API would be nice. I don't think it's coming. It might come in the very far future. That's why it's kind of the bottom bullet. And that's pretty much it. So I did use some icons from the Noun project. If you're doing presentations, they have free icons that you just have to give credit for. There's a credit slide. We're hiring, as the sign says over there. Thank you. You can follow me on Twitter, but I don't really tweet much, so I just don't bother, unless you have questions. So yeah, so questions. Yes.
Wait a second. Wait.
Sorry. Oh, good call. Microphone.
For the receiver list, where we are storing the offset, does it always have to be Zookeeper? Can we store it in like Redis or?
Oh yeah. You can store it wherever you want. Just Zookeeper is the standard one. At least it was a standard one. I believe in 0.9 or 1.0 of Kafka, they're actually doing their own offset management. Like using Kafka topics for consumer groups, but Zookeeper was the traditional way of doing it, so that's why we did it that way. But I'm sure like Redis or any of those other stores of data would work just fine. Zookeeper just is really good at not failing. It's probably like one of the best designed distributed systems ever. It just works. Like again, sounding hipster here.
Hi. Also on the subject of Zookeeper. Did I understand right that you're processing 14,000 events a second? 14,000 events a second?
The ones of interest, the topics of interest are 14,000 events a second.
So are you trying to write 14,000 counts to Zookeeper?
No. So how it works, I guess I can explain that a little bit better. Yeah, so each RDD is one commit to Zookeeper. So after you process that RDD, after every single one's done, you look at all of the Kafka partitions involved for all of the Kafka topics involved. You take the most recent offset and you commit those to Zookeeper. So in our case, for one job, let's say you have 32 topics, or 32 partitions on one topic, that would be 32 writes to Zookeeper every 30 seconds. So like nothing. Yeah, but then we do have like, I think 15 streaming jobs, so like it's still nothing. Zookeeper is pretty good at, I believe it's pretty good at standing up to writes.
In my experience, it isn't.
No?
It's actually crap once you're over.
Oh, that's, well, luckily we're only at 15 streaming jobs. So maybe, yeah, rely on Kafka or something. I think Kafka's pretty good at writes. But I mean, it is pretty good at writes. More questions?
Yeah, there's one right here.
Oh, sorry.
So you talked about from Kafka onwards, and you said that in Kafka the ordering is guaranteed in like each partition, but this is the ordering in terms of event
Yeah.
receive. So are you doing anything before Kafka to reorder events before in terms of?
So my understanding of how it works, yeah, we could receive them slightly out of order, which in our case isn't a huge problem. I think the Google Dataflow API might have some solutions to this, but
All right, so
yeah,
it's a big problem. It's a definitely
yeah.
problem.
I think how it works, and if someone knows more than I do, then they can correct me if I'm wrong, but I think how it works for us is we have some kind of, I think there's like the sysd message queue buffer, like Unix thing. Whenever we produce the Kafka from our application, it actually writes to that first, and every like 100 milliseconds that's flushed out. So I guess it can come out of order within that little block, but again, it's not a huge concern for at least this problem. For like finance applications, that'd be a bigger concern though, for sure. Yeah.
Well, I have one question. First, how many listeners did you set up on Spark streaming for Kafka as Kafka listener?
Listeners, like as in like how many streaming jobs do we have, or what's the parallelism?
No, the listener is like it's like a dedicated thread.
This is the Spark concept, right? The
Yes.
listener? We stick to Python, and I don't think that's. Do you know anything about that, Dave? No. Yeah, I think that's more of a Scala thing, isn't it?
Yeah.
Yeah, I only mostly know about the Python API. Like I have done a little bit with the Scala API, but most of our jobs are Python. So,
Okay.
do you know how it translates to Python? The listener?
The way I see it, by default, regardless of what language you use, what API you use, by default, Spark streaming always set up one thread for as an event listener, and in case of Kafka, it might be overrun. I'm not sure if you have.
So on the master, I believe it's just one thread, and I don't think there's any parallelism on the master. It uses, out of the box, if you use the direct method or the receiverlyst method, it will have one partition for each Kafka topic, or for each Kafka partition, sorry. So the partitioning is 1-to-1, so that's where the parallelism comes in.
The partitioning is 1-to-1.
Yeah, with Kafka. So it's confusing because it's like Kafka partition and Spark partition. They're different things, but they map 1-to-1. Yeah? Yeah, sure. Go ahead.
So in Spark streaming, the job scheduler runs as a daemon thread. So let's say you have your application, you can have one thread in the background, scheduling, based on your batch interval type. You can hit the job generator. A job generator will hit your beginning of your DAG. So for the direct Kafka input stream, it's going to call get or compute. So it'll hit cache, otherwise it will run Spark jobs. So it's a normal function, right? Give a task context, gives us time. It goes it fetches the offsets. It calculates what offset it should actually calculate fetch, and then makes 16 jobs per partition. Well, if you have 16 partitions, makes one Spark job per partition, and schedules it over your Spark cluster. So if you say your Spark cluster, you have 4 workers dedicated to this
I think that's in 2.0, right? Yeah. Summer? Summer. Woo, the future is now. I think that's it. Thank you.
Thank you.
I screwed this up. Turn off the mic. Yeah. Cool.
Success.
Success. All right. So I'll reset for you. Cool. Awesome. Hello. Everybody hear me all right? No? All right. Cool. I'm Sean. I've been here once before. Some of you guys might remember me. Some of you might not. Thanks to everyone who came to my workshop last night. It totally didn't go off without a hitch, but that's okay because it was the first time. We'll be running another one probably in a few weeks, so keep an eye out for that Intro to Spark workshop. So I'm here today to talk about sustainable Spark development. And I work at a company called Uncharted, which has apparently a cool logo. Thanks, man. So let's talk about the problem that I'm talking about. So Uncharted, in a nutshell, we do visual analytics applications for people. It's sort of a consulting company. We build applications that help people understand big data visually, basically. But visualization is a broad term these days. It's a very difficult problem to solve. And it often involves a lot of data processing beforehand so that you can actually create something that's digestible and usable. So you're looking at doing a lot of data science, you're looking at doing machine learning, data cleaning and enrichment, et cetera. And let's look at it from a different perspective. There's a lot of humans that work at my company, always a good thing. We have data scientists, we have computer scientists, engineers, DevOps, and like a whole bunch of other kinds of people. And all of them are working together to develop these applications. And really, it always kind of goes the same way. The what always happens explanation of our development workflow. So it starts with data collection, right? We get some data from some source. That's usually our DevOps working together with some engineers that are writing scripts to harvest that information from an API, let's say Twitter, maybe something like that. We then do some exploratory data analysis on that data. So that would be a data scientist who's going to go in and look for something interesting, going to look for something that has insight potentially for the customer or potential customer. There's application development that happens after that, and also concurrently, where our software engineers are working to develop some UI, visualization ideas around that information. We're going back and forth a lot with the data scientists to say, you know, what kind of conclusions might we draw from this and how might we show them to people. Then there's a bit of algorithm optimization that's going on. So you've got some people who know a lot about algorithms that are taking a look at what the data scientists have created and, you know, making it run in 4 minutes instead of 40 minutes, which happens all the time with Spark. And then you got your deployment and your scaling, where you're sending it over to the customer or something, and you need to make sure that it runs on like way more data than the test data that you had. And DevOps is coming back in at that point and working with the engineers. So there's a bunch of issues with this workflow. One is that everybody pretty much ends up touching Spark. It's really not a good thing. Two, and this is sort of why, Spark is really hard to learn and it's hard to use correctly. So when you have a lot of people from a lot of different backgrounds, like data scientists and software engineers and whatnot, they're going to approach that in a different way. They're going to write different kinds of code, and it doesn't really always jive really well. Scripts that are written for data analysis, they're often like productionized really quickly because we're on a deadline or something. And so something that the data scientist threw together, great that it works, kind of gets thrown right into production right away and doesn't really pass through any optimization or anything like that. And the real problem is that those scripts are not sufficiently modular to reuse. So every single time someone needs to play with Twitter data or something, they're trying to figure out how to copy paste blocks of code and, you know, asking Jim, like, how the hell did you parse this thing or fix this column or whatever, and sharing these long unintelligible scripts with each other. And it became really clear really quickly that this just isn't going to work, right? We're not going to be writing software very productively for Spark if that's what we're doing. So sustainability. When I say that word, I'm looking at a bunch of priorities. So the first one is I really want to kind of retain the productivity and flexibility that is afforded by scripting. That's a good thing, even though it doesn't always result in good software.
And we need to balance that with a need for modularity for those scripts. We want to promote a lot of code reuse and composability so that we're not always having to ask each other questions and stuff like that. And we want to reduce barriers to entry for new team members. This is another big one. A lot of people don't know Spark. It's a relatively new technology, and so you hire someone, they're really smart, but like they've never used that API before. They've never even maybe done MapReduce. So there's a lot to learn, and Spark isn't always super intuitive. So you want to kind of make sure that they're as productive as possible, as quickly as possible. So I'm here today to talk a little bit about what our solution was to this problem. It was a library called SparkPipe that I've been working on for a while. You can play with it anytime you want. It's on Maven. It's open source. And really what it's about is this. So this is a small script that adds a column to a data frame coming from a bunch of tweets that are pulled from the Twitter API. So, it's like pretty understandable, right? Like you look at it, you know what it's doing. I don't. It's ridiculous. That is way too long for what that does, and that's like a snippet of a bigger script that I couldn't even fit on that slide. It's at least unintuitive and not always the cleanest thing in the world. So what I'm aiming for with SparkPipe is to make certain things a lot simpler and more semantically clear. So this would be the same thing done with SparkPipe. So we have some built-in operations, we have a pipeline concept in this library. And really what we're trying to do is make that code more readable. That was kind of step one. And the idea really was that, developers shouldn't have to reinvent the wheel on some of these simpler tasks. So the one I was showing before is really a good example of like something you might do when you're doing data enrichment, where you're going to look at the columns that are already there that have some really raw information. And then you want to take something out of that and turn it into another column in the same data frame, but keep what you had before. And so, yeah, this definitely makes it a lot cleaner. And more importantly, though, I want to reduce a lot of boilerplate as well. And we're going to do that by creating domain-specific libraries as well. So I mentioned Twitter data. We've got one for Twitter-related operations that deal with data from the Twitter API, but we're working on others as well. And the good thing about this approach is that the operation really became the single modular unit that all the developers could agree on and the data scientists could agree on, as opposed to taking like kind of more traditional software engineering approach to this, where we could say, well, we'll just write better code. We'll do some object-oriented stuff maybe, or like something like that. Data scientists, they're not always that familiar with these programming paradigms. So we wanted to keep it really, really simple. And in this particular case, this is really as simple as you can get. It's a function. It's a function that has certain inputs. It has certain arguments first, actually, then the input, followed by the output. And it does something. It transforms a data frame in this case. And the real great part about this is that every one of those operations should do one thing and do it well. And this is like not a new idea, right? This is just really Unix, but for Spark. And frankly, like even if it doesn't do it well, that's okay, because at least it's isolated and I can come in and fix it later. I can make it more efficient. I can make it use less memory, run faster, etc. But we've agreed upon an interface, right? That's what we want. So what were some of the advantages for us as a business? Well, for one thing, pipelines are still highly scriptable. They have massive advantages, and I'll get into that in a minute. But they don't stand in your way. That was like the first priority from before. The second thing was isolating our developers from changes in the underlying Spark API. Spark is still, like I said, relatively new, and it's undergoing a lot of change all the time. So we had people who were really familiar with RDDs, then data frames happened, and it's like, well, crap, we all have to learn a bunch of new stuff. And now in Spark 2.0, data sets are happening and data frames aren't going to be a thing anymore. So it's like more learning again to really just do the same thing in a different way. So I really wanted to make sure that developers didn't always have to deal with that we could isolate some of that inside kind of a core company library of operations. We want to hide the uglier parts of Spark as well, like the code snippet that I mentioned before. Some things just aren't intuitive. Some things are really easy to get wrong and do slowly. So taking those and kind of making them into operations has a lot of advantages. And really, we're looking at creating reusable bits so that a guy can say, hey, I've got a function for that, and share it with his coworker. Productionizing those scripts and optimizing later. And most importantly, we have a very simple DSL, which encourages people to use this specific format when they're writing their code, and also separate the structure of their script from the implementation details. And what do I mean by that? Well, basically this. The idea is, even if I don't understand what each of the operations do or how they work, let's say, I'm not a data scientist. I know a bit about ML. I don't know as much as some of the people I work with. So I don't necessarily want to have to visually parse through a script that's 1,000 lines long, 500 of which I don't understand. With the pipeline, it at least makes it clear that, well, okay, I'm starting with some data ingestion, then I'm doing 2 analyses, branching off, and then I'm merging those back together and continuing on to do something else. And I can find the part that I'm supposed to fix or alter or change or reuse, incidentally, and then just work on that part or extract that part. So the bottom line here is that I'm not really trying to replace the Spark API. So you generally won't find operations that wrap simple things like select or something like that. Like, that's fine the way that it is. I'm not trying to do that. So was that on screen? Weird. It's not the same thing here as it is there. Okay. I'm just going to pretend that didn't happen. Yeah. And in particular, yeah, I'm just gonna look at this now. We're not trying to replace the Spark ML pipeline either. It's not even for the same thing. Those pipelines are linear. They're very dedicated to the Spark ML library. You can't really use them outside of that library. Though we do have operations for connecting it to our pipeline so that you can take your data ingestion, use it with Spark ML, and then connect it to like visualization afterwards. What do we got now? Mystery meat. So yeah, we have released Spark Pipe Core as open source, and it is available from Maven Central. You can pull it down and play with it if you're interested, but really why I'm here today is I need your help. So I really like using this. A lot of workers really like using this, and it's improved our productivity a lot. But what's really gonna make it a lot better is if people if you're interested anyway, create domain-specific libraries that work with certain kinds of data, certain kinds of logging formats, stuff that's important to you, and then are willing to share it with the community so that we can all stop writing a lot of boilerplate code and actually just do the important stuff, which is manipulating that data a lot faster. And if you are interested, let me know, because then I'll link to it. And that's really all I've got. So if you've got questions, fire away.
Any questions?
Blue shirt.
Well, everybody got here. Well, the first question, I guess, would be simple. You know that most data frame API is executed lazily. That means the schema of the data frame is resolved when you invoke the API, but the bulk of the data is only executed when the data frame is optimizing through a long casting to an RDD execution plan and eventually present to you.
Yep.
So does that API covers this part? That means if you subclass one of your pipeline, does it separate resolving of schema from the resolving of the real RDD plan?
Okay, so when it comes to the data frame operations that are part of Spark Pipe, and it's not a finished product by any measure. I mean, it's not 1.0 yet, so I'm still adding ops. But the ones that are there are to manipulate data frames. So each one takes a data frame as an input, and you get a data frame as an output. So it's not actually executing the data frame at all. In fact, when you run the pipeline, the output is a data frame, which you can then choose to run an action on, like first or collect or whatever you want, or not. So it's not doing anything differently than what you would be doing with Spark vanilla. It's more about making it more readable and more maintainable and easier to work with other people on. Does that answer your question?
Partially.
Okay.
Because the data frame, the execution plan of data frame is, I would say rather simple. It's they're just, very convenient.
Oh, absolutely. Yeah. Which is why we don't have ops for we don't have ops for selecting data or aware clause or anything like that. Yeah.
What you mean? running a machine learning on a
That's right.
data frame.
Yes.
And, iteratively until you reach a point, and that in which case the lazy execution represented as a Spark execution plan is kind of intractable.
Yeah, that would be horrible. That would be an example of a bad op, and it happens all the time. But the great thing about this is it's allowed us to separate like that, like writing something like that, it happens, right? In real life, people create those things. It's not right, but it happens. And so when they do, this has allowed us to kind of separate away the kind of requirements-driven development, which is how that kind of thing happens, and like core kind of Spark development. So our Spark experts spend more time looking at the internals of an operation like that and saying, hey, you know, this is not right. We're going to fix this for you, but we're going to maintain the interface that you had created yourself so that it looks the same. You know, you can keep running your script, but we just gave you a better version of that op. So we've reduced the number of people at our company who really need to be Spark experts, and we let them focus on that core kind of Spark, deep Spark knowledge like concepts, so that the data scientists can focus on data science instead.
Well, I guess it could work until, you know, the data engineer tries to push that part back into the trunk of Spark as we know, and eventually got rejected because, you know, Spark as we know wasn't. It could happen. So, well, you know, my first impression would be, you know, handle the lazy execution by yourself instead of relying on the execution and purely optimize Spark.
I'm not sure I understand your question at this point.
Maybe we can
I think you
follow
lost
up.
me. Come find me afterwards and we'll talk
Yes,
about
yes.
it. Yeah. Hey, how's it going, man?
Can Spark Pipe handle an entire pipeline from source to target? So let's say you download a CSV file from somewhere, and then you copy that into HDFS, for example.
Yeah.
And you do some enrichment. Let's say the CSV is customer address. The transform is, let's say, you geocode the address and you inject 2 column lat long into that CSV.
Yep.
And then you save the result into a Hive table. You append that into an existing Hive table.
Yeah, there are operations for those things. Yes. Well, that's the simple stuff. It's the domain-specific ones that are complicated. Those are taking longer.
Hi.
Yeah.
Oh, man, this always gets me. I like when people make these abstractions, when they kind of invert the control again. How does it affect your team when they, like, you made a successful pipeline, but the actual logic was kind of flawed? It compiles, but then it fails on runtime.
Sure.
Because logic was bad, let's say.
Yeah.
And then it throws a stack trace. But since you added this abstraction on top, how does it really affect you guys when you're debugging what happened?
So I haven't improved Spark stack traces. I apologize. That's still a mission. They're just going to spit out exactly what it would have spit out if you hadn't used the pipeline and written all those operations linearly in
Does
code.
the pipe abstraction add more?
No, it doesn't. Yeah,
Oh,
you're
so-
fine.
Okay.
Yeah, so it won't like make it worse, but it doesn't make it better either,
Oh, yeah, it's not-
unfortunately.
yeah, it's part stack trace. I think, yeah.
That's really just Spark's fault. But if I can do something, I will try.
Hi.
Hello.
Have you looked at the Apache Beam, the Google Airflow API for inspiration?
Yeah, I did a little bit. Does that one work on Spark yet?
I think Cloudrunner has this kind of library which takes Apache Beam API,
Yeah.
but still Spark. But I've been thinking about the same problem. I was wondering if I stuck to the Google Airflow API,
Yeah.
I could reuse the what which you want the data scientists to write. We could have that as a small portion, and then if it's streaming or it's ingestion. So I mean, I had the same idea. I was wondering if you were inspired, if you saw it and you learned from it.
I did see it. I think like ours predated that one. This one's been around for a really, really long time internally at the company. So this was me kind of trying to take what I thought was a really good idea and turn it into an open source library so everyone could use it. But yeah, I am looking at those continuously, both for inspiration and for potential operations to include as well. Yeah, for sure.
I was hesitant to ask this question because I know that you're creating a new library, and I love that you're going to open sourcing this. Thank you very much. But since you already asked about Apache Beam, I'm wondering if you have already looked at Keystone ML, which is integral part of the Spark ecosystem.
No, not really personally. I don't do a lot of ML myself. Tell me a bit about it.
Oh, it's just called Keystone ML, but it is a pipeline after all. It's instead of the two, it has an and then.
Yeah.
So you do something and then something and then something.
Does it support graph of like a graph pipe, or is it strictly linear? That's one thing I would look for. Because I have a few coworkers that are working on this with me as well. Some of them are more expert on that topic in particular. But one of the things that they definitely mentioned to me is that we are probably the only one they know of that has the graph operation, so that you can like merge and branch pipes. That's an advantage. Certainly as well, if you want to use operations from other libraries with that semantic, like you can. You don't have to use the ops that are bundled with Spark Pipe at all. Because from my perspective, they're just functions, right? Like it doesn't matter where they're coming from.
Wonderful, thank you.
Yeah, if they have graph stuff, then I'd love to know about it. Please send me an email or something. But if they don't, then that would be one thing you could get out of this.
Sure. Yeah, I think one last question.
Hey, Oliver.
Hi. I'm coming back to the sustainability side of things.
Yeah.
You've built a library that's hopefully great for new people that join Uncharted.
Yes.
And let's say they're not used to reading like Scala APIs and that kind of thing. Is there some sort of discovery mechanism or some other documentation, something that lets someone know there's a method that does this already for you?
You mean within my library, or yeah? So yeah, there is.
Within the company.
Yeah, so we have docs online for SparkPipe that document all the operations and kind of segment them by their areas of interest and whatnot. But it's something that I also want to improve a lot as time goes on and make it less Scala docky and more kind of like wiki-y, so that it's more human readable, especially for people who don't know Scala really well, which happens a lot at our company too. But yeah, it's an ongoing process. What's there right now is what you'll find on the website.
Cool.
Oh, thank you very much. Oh, yeah. Maybe we do one, because I think we're getting short on time.
Maybe one.
Can we do one more?
One over here.
I'll go grab it and run it back.
I'll be quick. What you're doing is reminding me of cascading, the library on top of MapReduce. And my experience with cascading was that very often I had a hard time figuring out what the actual MapReduce tasks were basically equivalent of the cascading operations. And this isn't so much a question, it's more a suggestion to document this the best way you can. Because when something would go wrong with cascading, it was a real nightmare to try and figure out what was going on.
That's very true. I think really this library is targeted for primary use by people who wouldn't want to know those details. Like I want to know those details because I'm a developer, right? But what I'm trying to do is smooth over the kind of right now what is a gulf between the data scientists that work at my company and the developers that work at my company, both of whom have to touch Spark. So I want them to kind of express their ideas this way so that I can go in and fix those things afterwards. And it's like the only way I found to create a separation of responsibility with Spark development. Because right now, Spark is a scripting engine. It isn't a software development platform. And I want to nudge it that other way, you know? But I hear you, and that's definitely a priority as well.
So thanks a lot, Sean.
Thanks, guys.
Another round of applause.
We'll take a 15-minute break and come back for our last speaker, who is on his way. He'll be showing us what's going on with Spark 2.0 and do some live scripting.